Welcome to qnawire.
For part A, we're going to use essentially Gauss's law. We know that then the electric flux would be equal to the enclosed charge divided by the permittivity of a vacuum. So this would be 6.20 times 10 to the negative 6 coulombs divided by 8.854 times 10 to the negative 12th coulomb squared per Newton meters squared. And we find that the electric flux then for part A is equaling 7.002 times 10 to the 5th Newton meters squared per coulomb. However, here this is for all sixes, and by symmetry, the flux is the same through each of the faces. So the flux through one single face would be, we can say the flux through a single face would be equaling 1/6 of this, because there are 6 faces to a cube. And this is equaling 1.17 times 10 to the 5th Newton meters squared per coulomb. This would be our final answer for part A. For part B, we know that in part A, we can say that the electric flux is independent of the size of the cube, because according to Gauss's law, the electric flux was simply dependent on that was enclosed. So essentially, the answer to part A, the electric flux would not change if the size of the cube was changed. That would be your answer for part B. That is the end of the solution. Thank you for watching.